Okay. How do you know? Well, okay. What's the equation of a linear line? There's three of them actually that you learned in grade 10. I just said one. Mx plus b. That's the first one. What does m represent? Which is? Anybody remember the formula? Flip it, because the rise are the y values, so y2 minus y1, and the run is the x values, x2 minus x1. That equation, slope is equal to rise over run, is equal to y2 minus y1, blah, blah, blah. That is one of the, I don't know what the word is, key factors in the development of calculus. You'll see that in a couple of weeks. All right. Okay, so we got slope. If you manipulate this equation, i.e. you multiply x2 minus x1 up to the other side, you get the second equation that you learned in grade 10. Oh, sorry, what is this equation called? Slope y-intercept equation, right? Because it gives you the slope and the y-intercept. B, we didn't talk about that. What's B? The y-intercept. So B is the y-intercept. So it's called the slope y-intercept form of the equation. If you manipulate this, you get what is called the point slope equation. Because it gives you the slope and a point, which is x1, y1. And then there's everybody's least favorite that everybody doesn't like in grade 10 because it doesn't have a lot of value in grade 10, but it starts to have more value as you move up. And that is standard form or general form. Remember that? Ax plus by plus c is equal to 0? No. It doesn't have a lot of value in grade 10 because it doesn't really give you the slope. You have to manipulate it to get slope and y-intercept. But it has value as you move up because as you move up in math, it gives you a way to write, well, when you go to multiple dimensions, like 3-dimensional, you don't have lines anymore, you have planes, right? 2 dimensions, this paper, you're looking at it, from where you just see the line, right? If it was perfect. But as soon as you add the 3rd dimension, you realize there's depth to it, and then you get the plane. And then that's x, y, and z if you're plotting it out. We don't do that in this class. That's second year calculus. So there's x, y, z would be coming like that. That's a z dimension coming out of the board. Okay? But that's second year calculus. So we don't really worry about that. And that's where this form, this standard form, starts to have more value. All right? Okay. Parallel and perpendicular lines. What are parallel lines? They never touch. Why do they never touch? Because they have the same slope. So they never ever touch because the slopes are the same. Right? If the slopes are different, at a certain point, they will converge and equal each other. So parallel lines have the same slope. What about perpendicular lines? What does that mean? If I say the lines are perpendicular, what does that mean? They meet at a 90-degree angle. So if the orange line here has slope of 2/3, and I say the yellow line is perpendicular. So the way I write a perpendicular slope is I'd put an M, and then I put a little 90-degree symbol there. That's just, yeah. Anyway, that's how I represent it. So what would the perpendicular slope be? Very close. -3/2. You can see it's going to be negative because it's sloping this way as opposed to this way, and it's the reciprocal. It's a negative reciprocal slope. So you get -3/2. You flip the fraction, multiply by, and it becomes negative. If you multiply these two slopes together, it always equals -1. Right? If you go m times m perpendicular, that's 2/3 times -3/2. Everything cancels, and you get -1. If you can multiply two slopes together and it equals -1, the lines are perpendicular. Okay? Just sort of floating around in your head somewhere from grade 10? All right. All right, let's do a couple of examples and then we'll pretty much be done for the day. What's the equation of a line that passes through the point 2, -1, and is perpendicular to the line 2x minus 3y minus 5 is equal to 0. So written in standard form just because that's a nice thing to do. And the book always puts its answers in general form, so we'll practice doing that right now. Okay. What do we do? What pieces of information do we need? What's one of the pieces of information that we need to figure out the equation of a linear line? Slope. So as soon as they say the word perpendicular or parallel to a line, that's the line you want to use to determine the slope. So right now it's in standard form or general form. I have to rewrite that to figure out the slope. So I want to put in mx plus b. You want to solve for y. Okay? So I'm going to move the 3y over. And then you'll divide off the 3. You get y is equal to 2/3 x minus 5/3. Okay. What's the slope of that line? 2/3, right? The number in front of the x. Now, I've said it is perpendicular to that line. So what's the slope of our line that we want? So m perpendicular is going to be -3/2. Flip, throw a negative in front, right? Okay, we got our slope. What other information do we have? There you go. You have the x and y values. And we have choices. We can use mx plus b, or you can use that. It doesn't matter which one you use. I'll do it both ways. Okay? So we have a point and we have a slope. I can put it into mx plus b. So I put the point to -1. So -1 is y. My m value is -3/2. My x value is 2. Whoops. And I solve for b. So I get -1 is equal to -3 plus b, because the 2's cancel. Move the 3 over. What's 3 minus 1? 2? Is that right? Did I do that math right? So our b value is 2. So therefore, the equation of the line is m plus 2. Yes? All right. If you do it with the other one, the point slope. I mean, you don't have to do it with both. Obviously, you can just pick one. Okay? So my x1, y1 are this. There's x1, there's y1. So if you put that into this equation, I'm going to get y minus. Now, it's subtracting a negative, so that means it's going to switch to positive. Does everybody understand that? Does that make sense? All right. My m value is -3/2, and x is 2. X minus 2. Dump this in. -3/2x. The 2's will cancel. I get +3. Move the 1 over. 3 minus 1 is 2. And you get the same thing. Yep. Okay. I didn't do anything. But you're welcome. We okay with that? All right. I'll give you one practice one, and then that'll be it for today. Oh, we got to put in standard form. Sorry. We have to write this in standard form, which is ax plus by plus c is equal to 0. Okay, what do you have to remember about standard form? No fractions, and one other thing. And this is, some books do it, some books don't, but I think this textbook does it. The x value can't be negative. Okay, so no fractions. So we have this. How do you clear a fraction? Other than making it a decimal. No decimals, no fractions. Yes, you take whatever the common denominator or multiple of that denominator is, multiply the whole equation by it. So in this case, if I multiply everything by 2, and you get 2y. -6/2 is just -3, right? It cancels the 2's. Plus 4. To not have negative x's. So which side am I moving everything to? The left side, or I guess for you, the left side. So then it's 3x plus 2y minus 4 equals 0. That's standard form. You can see why people don't like that, especially in grade 10. That does not look like that. Even though they are, it just looks a little weird. Okay? All the answers in the textbook will be written in that form. Okay. I'll give you one practice question, and then that's it. All right. Perpendicular. So what line? Give me an equation of line. In standard form. Just make it up, people. 18x. Ooh. Okay. Perpendicular to that line. Good luck with that slope. And passes through the point. What point? Thought you were gonna do fractions. We'll go with your first one, -4/6, because the slope's not gonna be nice that you generate there. Okay, go. I have to do this now too. Zara. I'll put it back up. I'm just gonna pause the video because I don't. And there's the answer, peoples.